Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews and on-site training. And of course, you should check out the video description for t-shirts, books, Patreon, ways to support this channel if you appreciate this kind of content. In this episode, I'm going to touch on something that I've somehow managed to avoid touching for the last 7 years on this channel, and that is chrono. So be sure you stick around for this episode. So if we go to cbpreference.com and look at the chrono header, which was first added in C++11, we can see that this is an awful lot of things going on here, and this is rather large with lots of capabilities, and some of these things were added in C++20, some of them started in C++11, but if you let your eyes just scroll over this, you can see there's lots of constexpr, which is of course always welcome. Now, I'm not going to cover this entire header and all of the capabilities of chrono because that is really just not how we do things at this channel. What I'm going to do instead is point you at this one succinct example that I carefully crafted the other day and have made available in the video description. But I'm going to walk through a few things with you about this so that you see what it is doing. Now, first of all, this is the system clock. We have in chrono not just a system clock. We also have a UTC clock, international time clock, GPS clock that is used for file time info, and the ability to interact with some sort of local time kind of thing. We also have steady clock and high resolution clock. Now, let's just say if you are doing any kind of timing data, you want steady clock because, as this says, this is a monotonic clock that will never be adjusted. That is relevant in the cases where you might get an update to your clock that occurs because of your system syncing with the atomic clock, or you might get a leap second or something random like that. No, you want the steady clock so that you are not ever dealing with system getting in your way of measuring time. This is using the system clock for the moment, and well, you can see when I actually executed this code. But let's go ahead and make this the UTC clock. Now, this will bring us to our very first point here, and that is that the chrono header is strongly typed. So I got something from the UTC clock, and I tried to subtract from the system clock, and you can't do that. These are two different clocks, and they are strongly typed, so it will not let us do this kind of thing. We have the current time, and then with this floor helper, we're effectively doing a cast from now to something that represents days. So let's keep that in mind. We've got now, we've got days, and then I've got some sort of offset, and that offset happens to be 75 hours. And I did that just for the fun of it. And then I have an offset ago. You'll see in a moment why I named them like I did, which is 10 weeks. Now note, these things are all, like I said, very strongly typed. So I am using standard format from C++20 plus calendar updates for chrono from C++20 plus the normal C++11 chrono that you might already be familiar with. So I am printing now, which is the full timestamp of when this code was executed, the days, which is the current clock truncated by the current date, year, month, day, and then the offset. So the offset is the 75 hours, followed by now plus the offset. So that should be the current calendar date and time plus 75 hours. And then the offset ago, which is 10 weeks. And then now minus 10 weeks. Let's go ahead and scroll over here. And so I have this date as my current UTC time. And then this is the truncated time. And then I am printing out that offset, and it automatically formatted it to say hours. So this is 75 hours from now would be this particular timestamp. And then this one is interesting because I have 10 weeks ago. And what this is actually telling me is 10 times 604,800 seconds ago, that's how many seconds are in a week, was this particular time. And then through this, I have measured how long it actually took to do this print by taking the current clock and subtracting the previous clock from it. And now I have a duration. And you will see here that I can do a duration cast. So I've got the complete duration, which is going to print in nanoseconds. We'll see that in a moment. I am casting that to microseconds and to milliseconds. And then just for the fun of it, I am casting it to a duration represented by a double. So I now get a floating point time. And you can see that it took 133,000 nanoseconds, which is truncated to 133 microseconds, which is 0 milliseconds. But if we do that double cast, then we can see it is 0.00133,137 seconds. So there you have it. This is Chrono in a nutshell. We've got date time features, calendar features, awesome formatting support with standard format. There is many different formatting options here. I went with the defaults for all of these. Several different clocks depending on your needs. The ability to add a date with an offset and get a new date, or subtract two dates from each other and get a duration. And if you try to do anything with any of these types that is outside of the scope of the meaning of them, then you will get a compile time error and you need to do some sort of cast to actually get the value that you're looking for. So note, as of C++20, it also has time zones and can deal with all of that kind of thing, including leap seconds and such. So again, I'm not going to dig into all this. I was just hoping to whet your appetite a bit for standard Chrono and its awesome new capabilities, taking into account standard format. And just so you know, you can access all of this information on cppreference.com and see all of the different format specifiers and everything that is possible with your format and Chrono and datetime integration. So thanks for watching this episode of C++ Weekly. I hope this was at least a little bit informative. Be sure to subscribe.